Hello, my friends. This is my first live stream. To be honest, I have never did live streaming before. Obviously, I participated in it. I took part in it multiple times, but I have never done it before on my own. So this is the first time I do it on my own end to end. Yes, and I already started seeing first comments. So, Mitya Nivelsky, thank you very much for joining. I'm really happy that you're here. Thank you. And I don't think this stream will take longer because the topic we have today is relatively simple. And other than that, I don't think that I'm ready to conduct quite a long stream. So let's start and let's see how it goes. Okay, so what you're going to do today? Today I want to write a consumer and producer pattern. What's consumer and producer pattern? The idea is relatively simple, but at the same time it is really widely used everywhere. So we have producers which produce kind of messages, we have consumers which read these messages and produce them somehow. And let's try to implement it in Java. The reason I want to do that is because it is quite often asked on technical interview, during coding challenges, and so on. So it's relatively popular topic. Because we don't have any special agenda for today, I think we could start. So I hope the font is big enough in order to see what I do. And what I want to start with is to explain what I prepared for the stream. So as you may see, I have nothing but a simple Maven project. This simple Maven project has no configuration. There is only one single thing. It is mainly Maven compiler plugin, and I intentionally set a release version to use latest Java version. It is 21, which was released roughly speaking a week ago. And if you're interested in new features introduced in Java 21, you can watch my short video with overview of the topics and overview of the jobs included into Java 21. And other than that, you can go and watch a Java Hut podcast with Roman Meyerson, our colleague Evgeny and me there. So let's start. Producer consumer pattern. So what I want to start with, I want to create an application. This will be my main class, and as you know, in Java 21 it is not strongly mandatory to write public class and name of the class. It is not necessary to write public static void main. It will work even without it. So what else? Other than that, I want to create a type for record. And record, or let's call it message. Message is something which my producers will produce and consumers will consume. So I want to use type. I don't want to use not a standard class, Lombok and so on, but I want to use a record, because record might be a bit more convenient here, because my message is an immutable type. It has only one single property. It is UUID, and in case if I create an ordinary DTO, I have to write getters and setters. But I want to make this class immutable, this type immutable, so that I want to start using records. Next step is to write a producer. So my idea is that I will start using the simplest possible approach you can find everywhere on YouTube, everywhere in Google, and next we will gradually improve it. So if you just joined us and see that I'm doing something not really good, please don't hesitate to put a comment to the chat, and please at the same time be patient, because I want to gradually improve it over time. So let me start with message producer. So message producer, in case if we start writing it in the simplest possible way, it should have And as majority of articles on YouTube, on Google, everywhere says that it should implement a runnable interface. The reason they ordinarily suggest to do it is because it's easier. Let's try to follow this approach, and again, let's implement a runnable interface. So step by step, we will get rid of it. Other than that, my message producer should know about the queue it will put messages to. So private final queue of messages, this is my queue, and I want to add a constructor, which will allow me to initialize everything in one go. So this approach allows me to avoid having setters, and this approach also allows me to set this queue value as soon as object is created. So what else I want to do, or what else I need to do? So my producer will instantly produce messages, so that I use while true and next queue, add a new message and UUID, random UUID. So that's it, obviously. This is my producer. And apart from producer, I need to have a consumer. Let me create another class. It will be message consumer. It will again implement a runnable interface. It is going to be as simple as possible, and it will have a queue of messages, queue as a dependency, so that I inject this dependency via constructor. And what else it will do? It will obviously run forever, while true. Next, while not queue is empty, while I have messages on the queue, it will pick a message from the queue. So this is my message. So if we take a look into the message definition, we will see that I used wrong method, because it retrieves but do not remove message from the queue, so that I need to use poll, because it not only retrieves but also remove message from the queue. So this is the basic thing. This is a basic thing. And what else I want to do is obviously I need to somehow notify that something is happening. So for example, message is produced, and here I want to put a message saying message is consumed. So I have producer, I have consumer, and next I need to join both of them together. I see a message from Med, and he asks, why is it so complicated? Can you write messages in Russian? Yes, of course, please go ahead. I don't think I use super complicated constructions in English, so that, and by my accent you can understand that both languages are quite good for me. So I can read and translate your messages from Russian to English, and what I want to do is I want to gradually scale my channel. So I noticed that my talks in English are a bit more popular. This is why I decided to conduct this talk in English. So, but in case if you want a separate stream to be conducted in Russia, please write it down to the comments. Maybe 1 or 2 streams we will conduct in Russia. I have no objections against doing that. So, anyway, thank you very much for watching me. Thank you very much for posting your comments. So, let me send you some emoji back. Thank you. Okay, let's move forward. So what we have? We already have message producer, message consumer, and now we need to join all of them together. This is what we need to do. Okay, the simplest way of doing that is, again, I'm saying it is not a proper way. As I said at the very beginning, we will gradually improve it. If you gradually improve, we will gradually improve it. Over time. So let's start with the simplest possible way. So what's next? I have message producer, message consumer, and now I need to join all of them together. And obviously they should work in parallel. Producer and consumer should work in parallel, right? I need to have a queue. First of all, this is my queue. This is my queue, but as you notice, queue is an interface. And there are many implementations, and the simplest of them is linked list, by the way. So what's next I need to do? I need to start a thread. No reactive programming today. What I'm gonna use today, I want to implement my own blocking queue and use virtual threads. So this is plan maximum for today. No reactive programming for today. So my producer and consumer should work in parallel. So I need to start a producer. Need to pass a queue there. This is my first thread. Let's call it producer threads. Yes, we will start with these two threads. New thread, new consumer, new message consumer and queue. This is my consumer thread. And I need to start both of them, by the way. Producer thread dot start, consumer thread dot start. Okay, so this is the simplest possible way we could do, and we notice that it doesn't work. I really like showing things which doesn't work because it shows what's wrong with it. Wow, I see messages produced, but I don't see messages consumed. So it says that messages are coming. So at least it works. Hooray, hooray, hooray. But I don't see messages are consumed, right? I hope you're still with me. Okay, so it seems that I don't have enough visibility of what is happening, right? Because I don't really see how many messages are in the queue. Maybe I have just message producer, and producer is extremely productive, but consumer can't consume so many messages. So what I want to do, I want to create a separate class called message logger. Again, it will implement runnable, and it will have private final queue of messages as a dependency. This is my queue. And what else it will do? Actually, what I wanted to do, well, before moving forward, I want to tell why I am following this approach, why I'm saying while true. So, you know, thread should work for some time. And the thread we have at least two threads at the moment, at least two. We will have three and even more. They have some shared data, some data and some objects which are shared across many threads. So that we should, roughly speaking, contact and deal with this shared media for some time. So that in case if I just run, for example, queue.add with a new message, what will happen at the end is my single message will be added and the execution of this thread message producer will be ended. The reason it happened is because actually the work is done. It just created one single message and then put message inside. Good? Not good. So I want my producer to produce message instantly. The same with message consumer. It will also consume messages until I have something to produce, and this while true is not an ideal at the moment, but we will find a way to improve it over time. It will also work constantly until my thread is alive. And also I have a message logger. What message logger will do is, so let me write it in the following way. It will do system out print, and next it will say string format r message count $s. I'm using string formatter here, queue size. And this is what I want to do. I want to create a third thread, new message logger queue, logger threads, and I also start a logger thread. So instead of just printing messages producer, messages consumed, I will print how many messages I see, how many messages are in the queue. So what we see is Well, it seems a number of messages in the queue grows constantly. I don't think I need to wait more because otherwise all the memory I have will be consumed. So we should do something with it, right? Because this is our first problem. Our messages are just produced instantly and nothing consumes them. Right, so you see message count grows. And here we come to the first obstacle we faced. We need to, instead of using, yes, Java 21 already has interpolation. And this is a fantastic thing. Why don't I use it? Because honestly, I haven't had a chance to use it. So let's use it. Thank you very much for suggestion. str, what should I do? I should put a string. This is my string interpolator, string template str. This is return of caret, as it said, as it's called, messages in the queue. And next I need to put queue, come on, queue size. Maybe str. Also there might be a different problem because I haven't selected Java 21 in the project. This is why it doesn't work. So language level is 20. My IntelliJ is not the latest one. This is why it doesn't. I still can't use it because I forget to edit. I forget to install latest version. So I'm sorry. Maybe next time. Messages in the queue. So queue size. Okay. Yeah, we can observe our. Yes, I need to update IntelliJ. Yes, we can. Thank you very much, Mitya, for your comment. Yes, we can observe using pattern observer, but this is not something I want to show. So right now we will have three threads, and all three threads will have their own responsibilities. So let's move forward. And also we have a second question in the chat. How to do consumer not to hold a thread but process message when it is received. It's a question from Alexei. That's a very good question. Unfortunately, we can't do it because we still need to have at least one thread which will consume all the messages which are coming to the consumer. And next, this consumer can produce another tasks for processing. So we still need to have a constant thread which runs constantly. And next it reads a message, at least in this approach. Other than that, we can write a queue in a different manner, and this queue, instead of just being a media between our producer and consumer, it also can have some callback. For example, do something, then message is consumed when message is added to the topic. So it depends on the implementation, and today we're going with very simple approach. Okay, let's get back to our challenge. The challenge we faced is that the message count grows constantly, and our consumer can't consume so many messages. So instead of using a simple linked list, we can use a blocking queue. Blocking queue is a queue which has a capacity, and the idea here is we can't add additional messages until, for example, until the queue has capacity. This is an interesting thing. And dealing with blocking queue is a bit different. So let's put a blocking queue as a type here, and also let's get back to our producer and consumer. We will update our producer and consumer a little. And what it will do, instead of just constantly and instantly adding messages to the queue, it will try to offer a message to the queue. And the difference here is that offer will insert linked block in queue. So what's up? Can conform. Linked block in queue. Just bear with me for a moment. Message. No, linked block in queue. 32. Block in the queue. Come on. I decided to use block in the queue because I don't want to use block in the queue. I want to use block in queue. So difference between block in queue and block in deck is that in queue it's a FIFO, block in deck we can read from both sides. So and again, I'm not saying that I will not conduct talks. I will not conduct talks in English. I will conduct talks in English only. I can conduct talks in Russian as well because I have no objections against doing that. I'm just testing different formats. So in case if you like this stream and you want me to conduct more talks, I will be happy to do that. So. Other than that, definitely I will add my examples to Git somewhere. I have my own Git account and I will do it there. So, while I answered all your questions in the chat, what you may see here is that actually the Red, as our consumer and producer, finally managed to find a consensus, and we don't have many messages which are not consumed by consumer. And in case if our queue is full, producer is not putting messages onto it. So we could say finally, voila, everything works. But let's get back to our discussion and let's see what else we can improve. Let's move forward, and what I want to emphasize and stress your attention to right now is on implementation of consumer and producer. You know, one of the most popular questions on the interview is how can you interrupt a thread? And how to interrupt the thread? And the possible answer would be, or how to stop a thread would be thread dot it's deprecated already, but previously it was possible to stop a thread, and nevertheless the correct answer is that you can't stop a thread, you can just interrupt a thread. And in order to interrupt a thread, you need to use a construction thread current thread is interrupted. So what it allows you to do, it allows to know if current thread is interrupted. Next, when thread is interrupted, you can stop processing. So instead of just having while true, what else you can use is while thread is interrupted. Because it's much better, because it allows you to stop processing in certain amounts at certain point in time. So instead of just running on while true, when you don't have an opportunity to stop the thread, now by having current thread is interrupted, you can stop the thread. But the main question is how should you send this signal? And to send this signal, you can use, for example, thread .sleep. I will, for example, allow my application to work for 5 seconds. It should throw an exception, and next I will interrupt a consumer thread. I call interrupt method. So after 5 seconds of normal work, my consumer will stop, and you will see that message will be full. So that's it. So you see messages in the queue is 32, and it happened just because my consumer thread is interrupted, and what it means that consumer thread is stopped and it does not consume messages anymore. Okay, voila, this is what I wanted to show so far, but we need to move forward. If I take a look into this code, I noticed that actually in 2023 it's not a good idea to create and manage threads on your own, because roughly speaking you need to not only to create threads, also you need to be sure that, for example, you don't forget to kill the thread at a particular moment, to stop the thread, and so on. And in the real life, you never create threads manually in a way new thread. Right, yeah, thank you for the like. Because in Java we have a fantastic tool which is called executor service. So in case if you need to deal with threads, please always use executor service. Executor service is a class, and you can obtain executor service via executors. Is it an interface? No, via executors class, and it allows you to create different kind of objects and first of all different kind of threads, of thread pools. So what's the idea of thread pool? So right now when I create a thread using new thread, I create a single thread, right? Right. But the point is quite often I need to have more than one thread because I need to create thread, I need to make sure the thread is still alive. In case of thread accidentally dead, I need to move my work to a different thread. And actually in majority of scenarios we use threads to distribute the work, right? We don't create threads just because we want to create a thread, we want to have a thread to distribute the work. And again, we can't create threads instantly because resources of our computer might be limited. For example, we start our application in container so that it has a quite limited number of resources, quite limited number of CPUs, so that it will have limited number of threads. And we'll get back to virtual threads in a moment. So it's better to use executor service, which allows you to submit your work instead of creating threads. So executors is an entry point here, and it has many different thread pools which allow you to create different kind of thread pools. So what else we have here? New cache thread pool. Idea is simple. We create thread pool, and in case if one thread is free, it for example it finally accomplished its work, job is done, it now can move and take another work to do. Single thread pool executor. It's very good for debugging purposes when you don't want to have multiple threads, but you still want to play with it. So scheduled pool executor. It's an interesting pool executor which, well, allow you to do, roughly speaking, simply some work over some time. Other than that, we have fixed thread pool, which allow us to have a thread pool of multiple but fixed number of threads. So let's start with simplest. For example, I want to have a thread pool of 10 threads, and this is my executor service. And what's interesting is executor service is auto-closable, so that we should remember that we should try with resources for dealing with it. Okay, so what executor service allows us to do? Executor service allows us to submit our work. So see, instead of just creating a thread itself, we need to extract our work, separate this is work, this is thread. And what we need to do? We need to do a work. We don't have to manage threads. And executor service allows us to get rid of this burden of managing threads. We now only deal with work. This is important. And in order to submit a work, in order to send work to be executed, we have two methods. It is in the executor service, it's invoke. It allows us to provide a collection of work, and it's submit. And what's interesting is it accepts both runnable and callable. And in the chat we have a question: if modern developer needs to deal with thread pools on its own, or frameworks are mostly responsible for that? And the answer is, in majority of scenarios you don't have to deal with thread pools on your own until you need to effectively process big amount of data. So again, in the majority of scenarios you don't have to deal with it on your own. And the next, let's say, level is you have a framework, for example, Spring Framework, and it has a fantastic abstraction called Task Executor. And this Task Executor allows you to do quite the same, but in a bit different manner. And it exists because it was invented before, it allows you to do, it was invented before executor service. And it's also suitable for majority of scenarios, but also you also may have a case when you need to, for example, process data and you don't want to rely on the framework. This is the first point. The second point is, apart from having a standard thread pool, which allows you to just do parallel processing of the work, we also have, if I remember correctly, fork join thread pool, which is suitable for hierarchical workloads. For example, for scenarios when you can follow MapReduce pattern. Roughly speaking, you have big work which can be split into multiple small pieces, and next results from small pieces can be back joined together. So it really depends on the workload you have. So answer from Alexei is very relevant. Yes, there are many high-level things which allow you to deal with concurrency easily, but other than that, it's extremely useful to understand what lays behind. So I want to put a like. Let me try to put a like. I'm not really good at streaming, so I will do my best to send a like. So thank you. Thank you for answering. And this is very relevant answer. Okay, so what I want to do, I want to submit my work, my thread, I don't need to create a thread anymore, my message logger, so this is my message logger. Executor server submit new message producer, this is queue, and this is message consumer. Message consumer, so this is what, as you may see, it should show the same result. Yeah, so I have messages in the queue. It works. Let's try to play around. Let's play around. And answer from Matt is also absolutely relevant, that in majority of scenarios you don't have to deal with it. You have to deal with it really not really often, but still it's extremely useful, especially in scenario when you want to understand what lays behind. Okay, let's create more message producers and more message consumers. Let's create 5, just because I can, just to see that everything works. Okay, it still works. We're quite happy. I hope we're happy. Let's take a step forward, and Java 21 allowed us to use virtual threads. And in order to start using virtual thread instead of regular threads, new virtual thread per task executor. So we just change type of the executor and it continues to work. Okay, it says that I need to enable, I need to use fresher version of IntelliJ to start using it. This is what it says to me. Yeah, so in Java 21 we also received a virtual thread task executor, which allows us to use less platform threads. So idea is also one thing which was mentioned here at the beginning, is it about reactive programming or not? And reactive programming was created as a trade-off, because in case if you have high volume of requests, you may notice that your thread pools, your thread pool is exhausted, and so that not all the requests can be produced, not all the requests can be processed successfully. So that created an idea, why don't we separate work from the thread? Why don't we, for example, split our work into meaningful pieces like transformation, MapReduce operations? And next we will use a limited number of threads to process all these requests. Instead of just saying this is the thread which do some work, I want to end-to-end. What I want to do, I want to build a pipeline which will say, after processing message A, I need to send this message to the consumer B, and so on. And this created, roughly speaking, this created reactive programming. When we, instead of having a sequence of operations, we have a pipeline of data processing. But the main problem with reactive programming is that it's expensive and it's really hard to understand it. It's extremely hard to debug it because mainly it relies on the pipeline, but not on something which you can easily read and code. Virtual threads is a great improvement in Java 21. It survived 3 previews, and the idea is that we have a career thread, and on top of this career thread we can create virtual threads which are written in Java, which are lightweight, which we can create almost instantly. And the idea is that when thread finishes its work, we can just unload this virtual thread from our career thread and put another virtual thread on top of it, and work will continue. So it's quite same idea, but using a bit different programming abstractions. Okay, so moving forward, hope it at least a little answered the question what's a virtual threads, and I strongly recommend you to, if you want me to tell more about virtual threads, please write comments, and we'll have a separate session and we'll talk more about virtual threads. The last one thing I wanted to show you today is a queue, what's inside the blocking queue and how we can create our own blocking queue using concurrent primitives. So let's create an interface called myQueue, and it will be a generified interface, and it will have a couple of methods saying offer t message and poll a message. Poll a message. No, next step is we will write our own queue, our own blocking queue. Okay, so this will be my blocking queue, because I suppose it's really interesting to write your own blocking queue. At least it allows you to understand how it works. Oops, I forget to use generic. Generic here. It's of type T. So this is my queue. This is my queue. This is my blocking queue. Sorry, my queue. Where is my blocking queue? And obviously it should have private int capacity, private final int capacity. So let's write the queue and let's take a look into the blocking queue, what's inside. So my blocking queue. And the next step is that I need to slightly fix, also I need to have a size, int size, just to know that everything to work as it was working before. Message producer, it will deal with my queue. Message consumer, it also will deal with my own queue. Is empty, let's simplify it a little. While some queue size is not equal to 0, I will read messages from it. So, yep. Yeah, there will be recording, obviously, of course, it will be available on YouTube. No worries, no worries, no worries. Okay, so what we're doing, I decided to write my own implementation of the queue, because I suppose it's also interesting. Because we already know how to create producer, how to create consumer, how to make them running in parallel, how to stop if we want, and the last one bit is a queue, which is in the middle. What else we learned today is that it's not necessary to deal with threads on your own. You don't have to create it on your own. You can use executor service, and the last bit we haven't touched is a queue, which is in the middle. So let's write our own queue, because I think it is quite interesting. Okay. So, what's idea, if we get back to the beginning of this live stream, you may remember that initially I used a linked list for storing messages, and linked list is quite useful data structure. We will use it again for storing messages inside the blocking queue, but the main question is how to make a queue blocking, right? Because see, the queue is blocking because it doesn't allow us to add additional messages in case if it is full, right? And it doesn't allow to read the messages if there is nothing to read. That's an interesting bit. So let's start and write it. So let me have a linked list of T. This is internal queue. Messages. Let me call it messages because I think messages it's easier to write than queue because queue is completely long. So method size will work in the same way, but messages offer method will work similarly, and messages poll messages poll will read and remove. Okay, so we have our own queue right now. Let's run and let's see how it works. Okay, we see this is not a bounded queue. So as you may see, number of messages in the queue constantly grows and consumers don't have enough capacity or resources to consume all the messages. And now we need to start blocking the queue. Now we need to start making the queue blocking. Idea is we have in Java we have many primitives, and the primitive which we're gonna use today is reentrant lock. New reentrant lock. And private final condition read, and we create two conditions: has capacity, lock new condition, private final condition has messages, lock new condition. There is a question in the chat of final is for immutability and thread safety. Yes. So see, honestly, it's my personal preference because this private final here on properties allows me to. Okay, there are a few things because it's not really easy to answer this question. And the short answer, yes, it's for thread safety, mutability, and immutability. The longer answer is we have Java memory model, and Java memory model gives us a few guarantees like happens before, the word tearing is not allowed, and constructor free, saying that in case if we create an object, it will not be available until it's when we create an object, it will not be available for consumers until it's fully created. This is constructor freeze. And private final, apart from saying that object is immutable, it also says that it will not be available in partially created state. And third part is that I am clearly say to anyone who wanna use this call is well, the object is fully created and can't work without these dependencies. So this is also a way to define dependencies. Thank you very much, Alexey, for your suggestion to have some drawing. Yeah, I have some tools which I suppose will help me to make these sessions more descriptive, but let's start with what we have. Okay, so what I have, and I hope I answered the question. So it's not only for mutability and thread safety, but also because it's even a bit more convenient. Okay, I have two methods, poll and offer, and these methods should be blocked. And offer should be blocked in case if if my queue has no capacity. So roughly speaking, if size of the queue is equal to capacity, I need to say has capacity await, right? Right. So I have to wrap everything. It has capacity await. This is my first condition. And other than that, I want to say if size, if my no, so just bear with me for a moment. Size equal to 0 has messages await. Okay, we have a very good question from Vladislav, who asks if consumer can't read messages from producer, can we lose messages? And the answer is no. The answer is no, because messages will not be consumed. Well, it depends. as ordinary, I started to answer it depends, because we can have a bounded queue which allows our consumers to wait, and we have unbounded queues which allows to send messages even if our queue has no capacity. For example, ordinary it works in distributed system. For example, Kafka is a very good example of unbounded queue. It can be used for describing it. So idea is we have a buffer between our producers and consumers. We have producers and consumers, and we send messages into the queue, and next consumers, if they have capacity, they read messages. But in this exact example, our messages, producers are blocked. This is an interesting point. Thread of the producer is blocked, and it waits until the queue has capacity. So message is not lost. So again, honest answer, it depends on the scenario. You also may write a scenario when, in case of producer cannot produce message for a certain amount of time, it just gives up and drop off the message. You also may have a scenario when your producer just send the message and that's it, like fire and forget. And also you may have many different scenarios, and in different scenarios you have different queues in the middle. So thank you very much. That's a very good question, and it definitely allows us to understand what we need to do. And this is why Java has so many different structures. Okay, let's get back to what we write. So this is what we want to write. If our capacity is full, we don't accept any new messages. If we have nothing to produce, we say please wait, nothing to do. But in order to start using it, we need to lock. And this is where I start using my reentrant lock, and finally I need to unlock the lock. This is pattern of dealing with reentrant lock. Lock, and next inside the try finally block I need to unlock my lock. Okay. So this is first part. I also add the catch block, exception E, throw new runtime exception, just because I don't want to write any code for now, but let me get back to you and explain what's happening here. So what we're trying to achieve? We're trying to achieve a scenario when producer thread is blocked if our queue has no capacity, and consumer thread is also locked if there are no messages in the queue. We can do it using ordinary monitors. It will be not really, this is not the way it is implemented in Java, and it's better using a reentrant lock for conditions like this, for scenarios like this. If I run this code, so before running the code, I also need to explain a few things. Unlock 40, yeah. Thank you very much, but that's not the main problem. Thank you very much, Vladislav. You're okay. Let me tell you a little about the pattern of dealing with it. So we have reentrant lock, and the way of dealing with reentrant lock is we lock something. We can lock it interruptibly, saying that in case if I cannot unlock after a short amount of time, it will be unlocked automatically. But at the end, you need to have a finally block saying that I now unlock something. Okay. If I remember correctly, reentrant lock is not after closable, it is serializable, so that we can't use we can't use it in the try finally. So what else we have? We also created two conditions. These conditions allow us to block threads, and these locks and conditions need to be somehow notified. Well, you know, all the objects have wait notify method. This is the example, but this is what we want to use right now. So what we have? We have lock. We locked both of our conditions. And next, inside the lock, we need to check if we have capacity to accept the message. In case if we have no capacity, we say this condition should stop new messages from coming, we say capacity await, and our thread will wait here. Just because our producer thread will wait here, just because we said await. Our consumer thread will also wait here if there is no messages in the queue. But we also need to write one thing, has messages notify or signal. Instead of notify, we should use signal. Has capacity signal. What it allows us to do. So again, what's the main problem? Consumer is blocked until it has no messages to consume. So it's here. If our queue is empty, our internal queue is empty, we have nothing to consume. Producer is blocked until queue has capacity. So saying that a queue is full, nothing to produce, nothing to accept. And as soon as first messages, as soon as then maybe not the first, but next message is added, we need to say, okay, we have a next message to consume, so that we need to have to send the signal. So this is what you may see. We have two methods, and one method sends signals to another method saying, okay, you added a message, now another consumer can consume this message. And this is how the queue works. So as you may see, it consumes, it reads the messages, and everything works fine. Whew! And to be honest, that's all I wanted to show you today. Well, thank you very much for being with me today. Thank you very much for all your comments. It shows me what else I can do next. I will think about other streams. So if you have ideas of what you want to see next, please don't forget to put it in the chat. And also I have a question. I want to have the channel somewhere else, for example on Telegram, or maybe on Slack, or on Twitch, or maybe I forget the name, what's the modern tool for speaking for talking between people. It's Discord. So please write a comment what you suggest me to use, Telegram or Discord, or maybe Slack, and I will create a channel there. That's it for today. Thank you very much for being with me, and as ordinary, on Monday I will share another video on solving coding challenge on LeetCode. Thank you. Hope you enjoyed the video. See you next time, and I will definitely announce new streams when I have ideas for new streams.